The Sun is a rather uninteresting star. Our middle-aged Sun is content with its current, relatively small size while it continues to burn down the hydrogen in its core. Despite continuing in this manner for roughly additional 5 billion years, our star will eventually run out of hydrogen and begin fusing helium deep inside. Within a few 100 million years, this will cause the Sun to swell into a red giant. The Sun will gradually lose its outer layers after consuming the innermost planets, maybe including Earth, and eventually leave behind a smoldering white dwarf encircled by a lovely planetary nebula of blazing gas. Most celebrities lead a life that is rather picturesque. However, some celebrities have incredibly diverse experiences, just like anyone. So let's quickly review some of the most extreme stars in the universe. Presented by AWZ. Most significant, Scuti. The prefix super is sometimes the easiest method for astronomers to convey that something is absolutely amazing, just like in the DC universe. The same is true of Superman and supergiant stars, which is a fitting classification for Scuti, the largest star yet discovered. The Sun will eventually develop into a red behemoth. However, it might have eventually turned into a red supergiant if it had begun its life with a mass roughly a dozen times that of its current mass. Scuti has lost a significant amount of mass. The largest of these stars, also known as hypergiants, can enlarge to a size greater than 1,000 times that of the Sun. Scuti, however, is around 1,700 times wider than the Sun and is situated close to the Milky Way's core in the constellation Scutum. Astronomers at the German Bonn Observatories first catalogued Scuti in 1860 as part of a star survey. However, later analysis revealed Scuti's brightness varied over a period of roughly 740 days, prompting a reclassification as a variable star. Some of these stars exhibit variations in brightness due to causes outside of themselves, such being obscured by another star or being visible through clouds of gas and dust. However, internal physical changes, including pulsations, occur in intrinsic variables like Scuti. In the instance of Scuti, the brightness fluctuates because the object is constantly growing and shrinking, making it difficult to take precise measurements of its circumference. However, like all red supergiants, including Betelgeuse, Scuti will end its life abruptly. It will fiercely forge ever heavier elements after running out of helium fuel in its core. Scuti will eventually begin generating iron if it doesn't expel too much mass during the course of its remaining existence. For stars, producing iron is a death sentence. When a star forces two iron nuclei together, it doesn't produce any energy, unlike when it combines lighter elements. Instead, it absorbs energy from the surrounding space. The star no longer produces enough outward pressure to prevent it from collapsing under its own gravity, which results in a runaway collapse. The final outcome? A strong core collapse, type 2, supernova that will finally, if only momentarily, allow Earth's citizens to see Scuti. The largest, RMC 13601. It's not always what it seems. A star's mass is not always determined by its size alone. That is definitely the case with RMC 13601, the largest known star in the universe, which packs a lot of weight into a very small body. RMC 13601 is only around 30 times as wide as our star, despite being thought to have more than 300 times the mass of the Sun. RMC 13601 is just one of many blazing stars that are ionizing the gas within NGC 2070, which is the biggest satellite galaxy of the Milky Way, the Large Magellanic Cloud. The Tarantula Nebula, the strongest star-forming area in our local galaxy, is home to this enormous open star cluster. Astronomers now know that RMC 13601 is just one of more than 200 brilliant, massive stars nearby that are all included within the RMC 136 star cluster, according to studies made by the Hubble Space Telescope. Of these beacons, RMC 13601 shines the brightest. In addition to being the most massive star, RMC 13601 also holds the record for being the brightest star. RMC 13601 is believed to still be burning hydrogen in its core even though its exact age is still unknown. In fact, a 2016 study suggested that it may just be a few 100,000 to a million years old. Additionally, RMC 13601 is a rare Wolf-Rayet star, which means that it is exceedingly hot, rich in heavy elements, and equipped with tremendous stellar winds that are ejecting its outer layers. The star is anticipated to discharge enough gas at the end of its life to weigh slightly over 50 solar masses because of the star's extremely strong stellar winds, which have been measured to reach velocities of about 5.8 million miles per hour, 9.4 million kilometers per hour. That is still massive enough to create a stunning supernova, though. After all, supernova 1987A's parent star, which is also in the Large Magellanic Cloud, was barely 20 solar masses. Most compact, EBLM J0555-57 size counts when it comes to stars. A star that is very large consumes all of its fuel, making it live quickly and perish violently. A star can live an incredibly long life if it is small and light since it has a slow metabolism. But how little can a star really get? EBLM J0555-57 is, in fact, exactly at the limit. EBLM J0555-57 straddles the lower bound of what it takes to be a star, weighing only 85 times as much as Jupiter and measuring only slightly broader than Saturn. After discovering the tiny star in 2017, lead researcher Alexander Boeticher of the University of Cambridge noted in a press statement, "Our discovery illustrates how little stars may be." If the star had developed with a slightly lower mass, the hydrogen fusion reaction in its core would not have been able to continue, and the star would have changed into a brown dwarf. Brown dwarfs are not nearly planets and not quite stars. Their cores can only fusion a heavy form of hydrogen known as deuterium and perhaps lithium. According to astronomer Serge Dietrich of the Carnegie Institution for Science, who specializes in studying the tiniest stars, knowing the barrier that divides stars from brown dwarfs would increase our understanding of how both arise and evolve. Even though EBLM J0555-57 is little, there are other stars with masses that are comparable to its paltry size. For instance, TRAPPIST-1, a star with at least 7 rocky planets, has a mass of 0.089 m, which is just slightly higher than that of EBLM J0555-57. Learning more about the lives of the tiniest stars may aid researchers in finding possibly habitable, Earth-like planets around them because stars with less than 25% the mass of the Sun are the most prevalent type of stars and great prospects for hosting Earth-sized planets. The hottest, WR102. While stars may not follow the exact ratio set by this quote from the Chinese work Tao Te Ching from the 6th century BC, the essence is still valid. A star's lifespan decreases when its fuel is consumed more quickly. And for Wolf-Rayet stars, this is unquestionably the case. These stars not only burn very hot and brightly, but a large portion of their potential fuel is also launched into space by their stellar winds. With a surface temperature more than 35 times that of the Sun, WR102, the star with the highest surface temperature, is one of these Wolf-Rayets. Wolf-Rayet stars are available in a variety of flavors, just like Baskin-Robbins. The most massive star, RMC 13601, has a WN spectral type, which means it has a high concentration of ionized nitrogen as a result of the CNO cycle's rapid conversion of hydrogen to helium in its hot core. The hottest star, WR102, is a late-stage star with a surface that is significantly enriched in ionized oxygen, a type of Wolf-Rayet that is extremely uncommon. Overall, there are only about 10 WO-type Wolf-Rayet stars known to exist in the cosmos. Intense stellar winds are present on WR102, even for a Wolf-Rayet star. Currently, they are blowing away from the star's surface roughly the mass of a sun every 100,000 years. As a result, WR102 loses mass at a rate that is hundreds of millions of times greater than that of the Sun. Remember that WR102 would vanish entirely at this rate in less than 2 million years, despite the fact that it may not seem like much for a big star. But who has that much patience? In addition to its unusually high surface temperature and quick mass loss, WR102 is of interest to astronomers because it is a strong candidate to undergo a supernova explosion in the relatively near future. The worst outlook was reported for WR102 in a 2015 study that examined how much time certain WO-type Wolf-Rayets have before exploding as supernovae. WR102 is a post-core helium-burning star with a remaining lifetime of less than 2,000 years. This is all for today. Don't forget to like the video and subscribe our channel. Stay tuned with AWZ.